Hello everyone, this is your tutor AB and today we're going to be solving a question from the IB Physics November 2020 examinations. This is a paper 1 question, SL level, and was question 23 of the test. So let's get started. The question is, planet X has a gravitational field strength of 18 newtons per kg at its surface. Planet Y has the same density as X but 3 times the radius of X. What is the gravitational field strength of Y? So we know for all gravitational questions, gravitation related questions, we use the formula G is equal to Gm over R square. This formula deals with gravitational field strength. And so this is what we want to use in order to get our equations and write them in terms of each other, and that will give us our answer. So let me explain this further. Let's write a base formula for the gravitational field strength at the planet X surface. So planet X, the field strength can be, let's say G, gravitational constant, the mass, and notice there's no mass given here. They're talking about density. Whenever you need density in terms of a mass, we use the formula volume into density is mass, and that's what we need to use in this case because we need to write the equation in terms of density as that's what's given. So volume of a sphere is always 4 by 3 pi r cubed. R cubed can be the r is the radius of this planet X and the density d. We just put it as that variable, and the planet has again a radius of r, so bottom would be r square. We're just basically using this formula, gravitational field strength formula. And then for planet Y, we have to try writing it as similar as X as possible. So this can be, well, G dash. It can be the gravitational field constant G, the volume 4 by 3 pi. Instead of r cubed, we need to say 3r cubed because we know it's 3 times the radius. So instead of r, we substitute 3r cubed d over, and then instead of r we put in 3r, so it's 3r whole square. Okay, let's now simplify these further. Also, we do know that G is equal to 18 as that's what's given in this question right there. So let's just put that into this equation. 18 is equal to, let's simplify, r cubed and r square. So this is simply just G 4 by 3 pi r t. That's what G is equal to, right? You know what? Just to make it easier and make the last step a bit more clear, let's just still keep it as G for now, although we know that G is actually equal to 18. G is actually equal to 18, but let's keep that for now. And G dash simplified would be G 4 by 3 pi into 27 r d. Notice how I just cancelled the r squared and r cubed. I just went one step further, over 3. 27 and 3 can be divided, so then you can get here would be 9. And well, what's left is we now have not 27 and 3, sorry, I did this wrong. 27 and 9, this and this can cancel, this now becomes 3, and G dash can simply be written as 3 times G 4 by 3 pi r t, right? All I did was take this 3 outside of the equation and multiply to the whole thing. It's already multiplied, I haven't done anything else. But notice when I factored out the 3, we get G 4 by 3 pi r d. Does this not look similar? Yes, that is just this. And we know that G 4 by 3 pi r d is actually equal to G. So G dash is equal to 3G. And we know that G is equal to 18. So G dash, which is the gravitational field strength at the planet Y, is equal to 3 times 18, which is 54 Newton per kg. And that's our answer, 54. So is that an option? Yes, it is. That's option C. So we're done. Thank you very much.